All right, everyone, welcome. Today, we're going to do something really important. We're going to bridge that gap between the abstract math you learn in class and the very real-world, high-stakes decisions that get made in a business every single day. We'll be focusing on one of the most powerful tools out there, the quadratic function. And trust me, this is about way more than just finding x. This is about learning how to read the story a business tells through its numbers.
So let's start with the big one, the question every single business, from a tiny startup to a massive corporation, has to answer. You've got your product, you've got your market. How in the world do you figure out that sweet spot, that perfect number of units to produce that will give you the most profit possible without making too many and just wasting a ton of money?
Well, it turns out, when you graph the answer to that question, you almost always get a shape that looks kinda like a hill. It goes up, it peaks, and it comes back down. And that shape, that hill, well, in mathematics, we have a name for that. We call it a parabola. And the equation that creates this beautiful curve, the quadratic function, is what we're going to use to model the lifeblood of a business. It's profit. It really is the natural arc of growth, peak, and maturity.
Think about what this curve is actually telling us. It's a story, a really classic and intuitive business story. When you first start out, as you produce and sell your first units, your profits start to climb. You're building momentum. Then you hit that peak. That's the absolute highest profit you can possibly achieve. But here's the crucial part. If you just keep pushing, keep producing beyond that point, your profits will actually start to fall.
This model is so important because it actually reflects how businesses work in the real world. You see, if you just use a simpler linear model, a straight line, it would basically tell you that the more you sell, the more profit you'll make forever. And we all know that's just not true, right? The quadratic model is way more realistic because it accounts for things like diminishing returns and the fact that you can't just sell an infinite number of things.
Okay, so now for the fun part. Let's actually tear apart one of these profit functions and see how each piece of the equation tells a part of our business story. This is where the abstract numbers start to build a real narrative. All right, let's dive right in. Here is the model we're going to work with today. Now, before we go any farther, it's absolutely critical we get on the same page about our terms. P of X, that's our profit, and is measured in thousands of dollars. X is the number of items we're producing and selling, and, this is key, it's also in thousands. Every single part of this equation, that negative 300, the 40x, and that negative 0.5x squared, has a very specific and very important business meaning.
So, let's start at the end of the equation with that negative 300. What is that? In business, this represents your fixed costs. This is your starting line. And notice, it's in the red. Before you've sold a single thing, you've already had to spend money on rent for the factory, salaries for your key people, insurance, you name it. So if X is 0, meaning you've produced nothing, your profit is actually a loss of $300,000. It's the financial hole you have to dig out of every single month.
All right, moving on to the middle term, that plus 40x. Now this is your engine. This is the good stuff. It represents your revenue, your contribution margin. For every single unit of X, that's for every 1,000 items you sell, this term adds $40,000 to your profit. In the beginning, this is the powerful force that drives that upward slope of our profit parabola. It's the money you make from just doing what you do.
Now we get to the really interesting part, that first term, the negative 0.5x squared. And let me tell you, that little negative sign right in front, that is probably the most important part of this whole equation. Why? Because it's the reality check. It represents the forces of diminishing returns. Think about it. To sell more and more, you might have to spend more on marketing. Or maybe you have to run your factory overnight, paying people overtime, which is more expensive. This term is the mathematical voice of reason that says, hey, hold on. Unchecked growth eventually becomes inefficient and starts to cost you.
So we've established this rise and fall, this hill shape. The million-dollar question, or in this case, the multi-million-dollar question, is how do we find the exact top of that hill? We're not just going to guess. We're going to use a very precise, very elegant mathematical tool, the vertex formula. This little formula right here, x equals negative b over 2a, this is our roadmap to the peak. It gives us the x-coordinate of that highest point, which for us is our optimal production level. So let's look back at our equation. P of x equals negative 0.5x squared plus 40x minus 300. The a is our quadratic coefficient, negative 0.5, and b is our linear coefficient, 40. Now we just have to plug them in. You can see how the formula elegantly balances the force of growth, b, against that force of diminishing returns, a, to find that perfect sweet spot.
Okay, so let's plug in the numbers. We've got negative 40 on top, and on the bottom, 2 times negative 0.5.
Well, 2 times negative a half is just negative 1. So you have negative 40 divided by negative 1. And boom, positive 40. Now remember, our units, x is in thousands. This number, 40, is our magic number. It's telling us that the optimal quantity to produce to get the most profit is precisely 40,000 units.
Okay, so 40,000 units is the how, but what about the how much? What's the actual peak profit we can expect? To find that, we just take our optimal quantity, our x equals 40, and we plug it right back into our original profit function. And when you run the numbers, P of 40 comes out to 1,300. And again, remembering our units are in thousands, this means our maximum possible profit is $1,300,000. That is the peak of our mountain. That's the target you put on the whiteboard for the whole company.
And this, right here, this is the most important translation you will ever make as a business professional. You don't walk into the boardroom and say, well, the x-coordinate of the vertex is 40. No. You translate. You stand up and say, team, our models show that we hit peak profitability at a production level of 40,000 units. Marketing, I need a plan to support that sales volume. Operations, is our supply chain ready? Finance, what does a $1.3 million profit do for our quarterly forecast? You see, the math is the catalyst that starts a dozen other critical business conversations.
Now let's shift gears and talk about a trap, a really common and incredibly costly mistake that I see all the time in the business world. It's so easy to think that maximizing revenue, the total amount of cash coming in the door, is the same thing as maximizing profit, but it is absolutely not.
And this table just lays it out so clearly, doesn't it? Maximizing profit, that's all about the bottom line. It's a careful balancing act between your income and all your costs. Maximizing revenue, on the other hand, is just about the top line. It's a focus on sales volume at almost any cost. You could sell 1 million gizmos and bring in a ton of revenue, but still go bankrupt if it costs you more to make them than you're selling them for. Profit is the true measure of a healthy, sustainable business. And this is so important to understand. If your boss comes to you and says, I want to maximize revenue this quarter, you literally cannot use the same profit function we just did. You'd use a different one without the fixed costs in it, for example. And that would give you a different vertex, a different X, and a totally different business decision. That is why it is absolutely vital that you know precisely what metric you're being asked to optimize. The math will always give you an answer, but you have to be sure you're asking the right question.
Okay, so these models are amazing strategic tools, right? But like any powerful tool, if you don't know how to use it properly, you can do some real damage. So let's go over some of the most common mistakes I see students make, both on exams and more importantly, in real-world business plans.
Look at this list. I've seen them all, but if there's one I want you to burn into your memory, it's the first one, confusing the X value with the Y value. Confusing the how many with the how much. Remember, X is your decision, the number of units you make. P of X is the result, the profit you get. If you mix those up, you might tell your boss the goal is to make a profit of $40,000. That's a disaster. The goal is a $1.3 million profit, which you achieve by producing 40,000 units. The cause and effect here are absolutely critical.
We always have to approach these tools with a healthy dose of humility. There's a fantastic quote from the famous statistician George Box, and he said it best, all models are wrong, but some are useful. Our parabola model is a simplification of a very messy, complex world. It assumes things are stable. It gives us a strategic direction, a highly educated best guess, not an infallible prediction of the future.
So I'm going to leave you with a question to chew on. We found our perfect number in our perfect little mathematical world, 40,000 units. But what happens when the real world's chaos kicks in? What happens to our beautiful parabola when a new aggressive competitor slashes their prices? Or a global pandemic disrupts our supply chain and doubles our costs? How do those real-world shocks change our model and ultimately change our decision? That right there is the next level of business analysis.